Understanding CPU bursts and I/O bursts is essential for grasping how processes interact with the CPU and external devices in a computer system. A CPU burst is a period when a process actively uses the CPU to execute instructions. This is like a chef preparing a meal in the kitchen. The chef is actively using the kitchen to perform tasks. For example, when you open a web browser, the initial loading of the browser's interface is a CPU burst. The CPU is executing instructions to render the browser's UI. You can also think of it like a student working on a math problem. The time spent solving the problem is like a CPU burst. The student is actively using their brain to perform calculations. An I/O burst, on the other hand, occurs when a process is waiting for input-output operations to complete. This is similar to the chef taking a break to fetch ingredients from the pantry. The chef isn't actively cooking but is waiting for something else to happen. For instance, after loading the browser, if you click on a link to load a new web page, the time spent waiting for the web page to load from the internet is an I/O burst. The CPU is not actively executing instructions for this process. Instead, it's waiting for data from the network. You can also compare this to a student looking up a formula in a book. The time spent searching for the book and finding the formula is like an I/O burst. The student is not actively solving the problem but is waiting for information. Processes alternate between CPU bursts and I/O bursts in what's called a CPU I/O burst cycle. This cycle continues until the process completes its execution. For example, a text editor program might start with a CPU burst to load its interface, followed by an I/O burst as it waits for user input. Once the user types something, there's another CPU burst to process the input, followed by an I/O burst to display the output on the screen. You can also think of it like a factory production line. Machines assemble parts during CPU bursts, then wait for raw materials during I/O bursts, and repeat this cycle until the product is complete. Understanding these bursts helps in optimizing system performance by ensuring efficient use of resources and minimizing wait times.